Hi everyone, how are you doing? Even though you're doing a self-quarantine, I hope that you're all having a great day. So it's me, Ms. Fitria Rahmawati. Since we can't meet in the classroom, I will be explaining the lesson through the recorded videos. This video discusses the quantitative data analysis. The topic will be delivered in some parts, meaning there will be different videos. The first part will be about the instrument testing and the data screening. The second part will be discussing the descriptive statistics and the tutorials with the SPSS program. And the third part will be about the inferential statistics, including the SPSS tutorials too. So what you have here is the first video. So let's get started. Yeah. Here you're going to be exposed to the explanation on the instrument testing, which include the validity test and the reliability test, and also the data screening, including the missing data and the data outliers, while these two will be discussed in another video. So the first is about instrument testing. Materials in this slide adapted 3 different resources as seen in the screen, as what you can see in the screen. So in a quantitative method, there are 2 different types of instrument testing, which are called as the validity test and also the reliability test. Instrument testing is basically some test which should be conducted in order to make sure your research instruments, either you're having a questionnaire or you're having a test, is appropriate to be used, which later can be used to answer university questions. So the first instrument testing, which is we are discussing now, is the validity test. We have discussed a validity test last week, if you still remember, on our previous meeting, and we also have practiced on how to operate or conduct a validity test. So this is just for a quick review. Basically, undergraduate students are commonly required to conduct a content validity test. Yes, either to the questionnaire or to the test that you have. This is done by asking some experts to give a judgment or justification on each items of your instrument. Again, validity test is done to reveal each items of your instrument. So if you have 25 items, every item needs to be justified. Also, this validity test is conducted prior to the data collection or before you collect the data. Later, there's expert judgment which are presented in scores are analyzed using the icon test analysis. Your instruments are considered valid if the item's content validity coefficient, which is symbolized as V, belong to the average validity, which should be at least 0.4 or 0.4. So your every item is considered valid if the V score is at least 0.4. Yes. Next, we also have the reliability test. So reliability is related to consistency. It refers to how dependable or consistent an instrument measures a characteristics. Or in other words, reliability is the degree to which an assessment tool, either it is a questionnaire or it is a test, produces stable and consistent results. How can you know that your instrument is reliable? It is done or it is obtained by administering the same test twice over a period of time to a group of individuals. So if a person or a student takes the test again, the same test again, will he or she get a similar test score or a much different score? A test that yields similar scores for a person who repeats the test is said to measure a characteristic reliably. So it infers that the reliability test is conducted after the data collection or after you distribute your questionnaire or test to your respondents. In addition, reliability test is used to test the instrument as a whole. It is not intended to test item by items. So it differs from the validity test. The validity test tests your individual item, while the reliability test tests your instrument as a whole, right? Reliability test is analyzed by using the Cronbach alpha to measure the internal consistency, or it is also known as the alpha coefficient of reliability. And to see whether an instrument is reliable, the following guideline can be used. So here you can see this is the Cronbach alpha is symbolized like this. So your instrument is considered reliable if the coefficient alpha is minimum higher than 0.6. Once again, it is said that items are considered reliable if the Cronbach's alpha coefficient is higher than 0.6. However, in other references or in other books, some also required that the alpha should be higher than 0.7. Let's just agree. Let's just agree that your instruments is considered reliable if the Cronbach's alpha coefficient is higher than 0.7. As you can see here, the 0.7 is considered reliable. See? Okay. The tutorial of the reliability test is provided in a document, and it also has been uploaded on my class website, so you can check it. The next thing in this video is about data screening. So this discussion will cover the missing data and data outliers. What is data screening and why data screening should be conducted before analyzing the data? Data screening is a process of ensuring the data are clean and ready to go before conducting further statistical analysis. So your data must be screened in order to ensure the data are usable, reliable, and valid for testing causal theory. Yes. So data screening is conducted after you got the data from your respondents. And then the researcher input the data into the SPSS. Before conducting any statistical tests, data screening is conducted. It means data screening is done after the data gathering and before the statistical test. Right? So, what needs to be screened? The first one is the missing data. Missing data is a case in which the respondents missed to respond to one or more items or statements in your questionnaire. In order to check the missing data, please later refer to the and valid and missing and the range resulted from the SPSS analysis. Provide the sample after this slide. There is no missing data, so your questionnaire has no missing data if the n-valid missing score from all the questionnaire items is 0, meaning that all items had been responded. Another thing that you need to observe is the range score. What is range score? Range score is basically the response scale you have in your questionnaire. For example, 1 is for strongly disagree, 2 is for disagree, 3 neutral, 4 agree, and the last one, 5 is for strongly agree. The scale used, for example, here is 1 to 5. It means that there is no missing data if the range score is not more than 5 and or not less than 1. For example, here, this table is a sample resulted from an SPSS analysis on the data screening. So you can see the highlighted ones, the n valid and n missing. This is what I mean by n valid and n missing. N means the total number of valid and the total number of the missing. Valid here, as you can see, I have how many items? Right, I have 12 items in my questionnaire, and for the n valid, it shows the respondents. N valid shows the number of the respondents I have. So I have 35 respondents. It is said that there is no missing data if the n valid shows the total number of your participants. See, from items 1 to items 3, the number are 35. It means that all the 35 participants answer all the items. And also, you can see the n missing. The n missing should be 0. If you want there is no missing data, so the n missing should be 0. It means that all the participants respond to every items, just like what you see here. All right, good. All right, another thing regarding the data screening that needs attention is data outliers. Outliers are data values that differ greatly from the majority of a set of data. These values fall outside of an overall trend. If you remember, trend is the majority or the tendency that is present in the data. In other words, there are unusual values in your data set. So, there are some possible reasons causing data outliers to happen. The first cause is because of the measurement or input error. Measurement or input error is when a researcher mistakenly inputs the data or score in the SPSS. It usually happen when the researcher inputs a score manually. For example, the score from the respondent is 5, which is strongly agree. However, he mistakenly put 3 or 4 in the SPSS. The second reason that causes the data outlier is true outlier observation. This refers to the actual error made by the respondents. It can be because the respondent was not aware of the instruction or because he or she intentionally chose or voted the score. Well, you cannot expect your respondents to choose strongly agree for all the items you provided, right? They can disagree or even strongly disagree. It means that they can choose 2 or even 1 from the response that you provide. Another example is when you are conducting a test. Every student has different proficiency level. Data outliers, what is meant by true outlier observation is when a student resulted a very high score or even a very low score. So that's another example of true outlier observation. Then, why should a researcher be bothered with this data outlier? The reasons are because outliers are problematic to many statistical analyses because they can cause tests to either miss significant findings or distort real results. It means those data outliers can impact or influence your final results. Your data should be significant, but because there are outliers, your data can be not significant. You don't want that to happen, right? So, how are data outliers look like? You can see some of the data outliers from the samples I provided here. I provide quite various samples, including the simple data, the table, and also from both the box plot and the scatter plot. Start with the simple data. Here I have 1, 2, 3, 4, 5, and 9. Can you guess which data is the outlier? Exactly. 9 is considered as the outlier. Why? Because it differs greatly from the majority of the data set. You have 1, 2, 3, 4, 5, and suddenly you have 9 here. So 9 certainly looks like it could be an outlier. See? Another example can be seen from this table. Here is, for example, the score of your students' performance test. If you carefully take a look at these scores, which data is the candidate of the outlier? Which number seems to be different from the others? Correct. From all of these scores or grades, students number 6 gain 20, while the other students gain more than 60 or 65. These only students get 20 scores, that get 20 points. Yes, so this particular number, this data, is considered as the data outlier, all right? Because it's very different from the other data set. The next sample are resulted from the SPSS. Here is in the form of box plot. This is called as box plot. If you can compare from the items 3, which is this one, and item 8, this one, which item has the outlier? Can you guess? Good job. Yes, the data outliers are also present in item number 8. Can you see the dots here? This one, and these ones? Yes. Why are these dots, why are these data are called as the data outlier? Because these scores fall outside of an overall trend or from the majority of the data. Let me explain a little bit about that. So here we have two different groups, male and female. From the items, biasanya saya menggunakan body language dan ekspresi muka ketika sedang membaca keras untuk meningkatkan pemahaman saya. The male respondents mostly chose 2, 3, and 4. And most of them chose number 3. While these, for the female group, the response are various. Most of them answer 4, as you can see here. However, there are also some outliers. One female, which is respondents number 34, answer strongly disagree. Another one female respondent answer disagree, which is participant number 10. And there are 3 female respondents answers very agree, which is really different from the other data sets. So those are considered as the data outliers. See? The last sample here is in a form of scatter plot. As the name suggested, scatter plot, see, the data are scattered in such a way that they make a straight line, as you see here. And this one data is called as the data outlier. See, because it falls outside the other data set. So those are the examples of data outliers. Yes, so that's all about the instrument testing and the data screening. So in conclusion, there are steps that need to be conducted regarding your instruments in a quantitative method. The first is, of course, doing the instrument validity. Usually you aim for the content validity for the undergraduate students, which is done by doing the expert judgment, and then you analyze it with the icon test. And then after your instrument is valid, it is then ready to be distributed or administered to your respondents. Remember, don't forget about the minimum numbers required for the total respondents. And after you've done collecting the data, after there are enough response to your instrument, then you can proceed to the data input. So you input your data in the SPSS program, just like what we did last week. And after you input the data, either it is from a questionnaire or a test or both, what you do next is the data screening. Correct. Here you see whether you have a missing values or a data outliers. All right. And the last step before you conduct a statistical analysis is you do the reliability test. This is the last step to verify your instruments, which is done with the SPSS application after you got the data. By doing the reliability test, you got the idea whether or not you should omit or delete any of your instrument items. So that's all for now.